Hello guys, how are you doing? In the last couple of videos, we've talked about speed in great detail and we've also solved several problems on it. So I'm sure all of you are clear about the concept of speed. But as it turns out, sometimes just speed is not enough. To understand what I mean, consider a scenario. Imagine two cars, A and B, traveling at the speed of 50 kilometers per hour along the same straight line. So here we have two cars traveling along the same straight line at the same speed. Now, based on this information, can you tell me whether the two cars will collide or not? Well, if you really think about it, you can't say with 100% certainty that the cars would indeed collide, because the information of speed is not sufficient. The two cars, if they are moving in the same direction, then there is no question of collision, as the cars are traveling at the same speed. But if the cars, on the other hand, are moving in the opposite directions, then despite their speed, they will collide if they are moving on the same straight line. So here we have a crucial piece of information about the direction of the motion of two cars which is missing. And without that, we can't really say whether the cars would collide or not. So to get out of sticky situations like these, scientists define a new physical quantity called velocity. And no points for guessing, velocity is a vector quantity, which means it has both magnitude and direction. Now, I hinted you about the concept of velocity in one of the previous videos, so I hope most of you remember it. But in any case, formally, velocity is defined as the rate of change of displacement of an object with respect to time. Now, mathematically, we write this as velocity is equal to displacement divided by time. The magnitude of velocity is equal to the magnitude of displacement divided by time, while the direction of velocity is same as the direction of displacement of the object. Now compare this with the formula of speed, which says speed is equal to distance divided by time. So velocity is displacement divided by time, while speed is distance divided by time. Now just like we had instantaneous and average speed concepts, we also have instantaneous and average velocity concepts. And as you already know, instantaneous speed is nothing but the speed of a moving object at any instant of time, while average speed is basically total distance covered by the object divided by total time taken to cover that distance. Now, just like that, instantaneous velocity is the velocity of a moving object at any instant of time, while average velocity is total displacement covered by the object divided by total time taken to cover that displacement. Now, I want you to forget about instantaneous speed as well as instantaneous velocity because we need advanced mathematical tools to analyze them. So let's put our full focus in comparing the differences between average speed and average velocity. And for that, let's consider a scenario where Jack decides to travel to a nearby medical store in his neighborhood to buy some medicine. Now, the medical store is 5 kilometers due east from his house, and Jack arrives at the medical store in 10 minutes time. Now, while returning, Jack goes to one of his friend's house, which is 3 kilometers due west from the medical store. And once again, Jack takes 10 minutes to do so. Now, assuming point O represents Jack's house, point A represents the medical store, and point B represents Jack's friend's house, you are supposed to calculate the average speed and average velocity between the points O and A, as well as the points O and B. So go ahead and try solving this problem, guys. And once you do it successfully, you would be able to clearly see the difference between average speed and average velocity. Your time starts now. So guys, Jack's average speed between the points O and A comes out to be 30 kilometers per hour. Jack's average velocity between the points O and A comes out to be 30 kilometers per hour due east. Because velocity is a vector quantity, we have to specify its direction as well. Similarly, Jack's average speed between the points O and B comes out to be 24 kilometers per hour, while Jack's average velocity between points O and B comes out to be 6 kilometers per hour due east. Let's go ahead and see the solution. So the two main formulas that we need to solve this problem are average speed is equal to total distance divided by total time, and average velocity is equal to total displacement divided by total time. Now let's begin by considering points O and A first. what do you think is the total distance covered by Jack between these 2 points? Well, it's nothing but 5 kilometers. And what do you think is the total displacement covered by Jack between these 2 points? Well, you see, because displacement is a vector quantity, we need to define a sign convention first. Now, assuming right side to be positive and left side to be negative, our displacement comes out to be plus 5 kilometers, where the positive sign represents the right direction. Now, the time taken to cover this distance or this displacement is equal to 10 minutes, which is same as 10 by 60 hours or simply 1 by 6 hours. So, from here we can easily get the value of average speed as 5 kilometers divided by 1 by 6 hours, total distance divided by total time. So, this comes out to be 30 kilometers per hour. Similarly, we can get the value of average velocity as total displacement upon total time, which once again comes out to be plus 5 kilometers divided by 1 by 6. Now, this value comes out to be plus 30 kilometers per hour. Now, once again, the plus or the positive sign here shows the right direction. So here we have the average velocity pointing in the right direction. Now let's calculate the average speed and average velocity between the points O and B. But you see, Jack doesn't directly go from point O to point B. Rather, Jack first goes to point A from point O and then turns around to go to point B. Or in other words, Jack begins at his house, goes to the medical store first, and then turns around to go to his friend's house. So the total distance covered between the points O and B, OA plus AB, which is nothing but 5 plus 3 kilometers or 8 kilometers. So total distance covered in this case comes out to be 8 kilometers. Now we can also find the displacement between O and B by simply writing it as displacement from point O to A plus displacement from point A to B. Now the value of the first term here is clearly plus 5 kilometers. We found that out in the last part. But what is the value of the second term? Well, you see, it's actually minus 3 kilometers because the problem clearly says that Jack's friend's house is 3 kilometers due west from the pharmacy or from the drugstore. So the total displacement between the points O and B comes out to be 5 minus 3 kilometers or plus 2 kilometers. Now, the time taken by Jack to go from point A to B is 10 minutes. So total time taken by Jack to go from point O to point B is actually 10 plus 10 or 20 minutes. Now this, when we convert to hours, comes out to be 20 by 60 hours or 1 by 3 hours. Now it's very easy to find out the values of average speed as well as average velocity. Average speed in this case comes out to be total distance divided by total time, which is nothing but 8 kilometers divided by 1 by 3 hours. The answer here is 24 kilometers per hour. Similarly, average velocity is total displacement upon total time, which is plus 2 kilometers divided by 1 by 3 hours, which comes out to be plus 6 kilometers per hour. And with that, let's end our video today, guys. I hope you had a good time understanding the concept of velocity and how it stacks up against the concept of speed. Now, in the next video, we'll talk about acceleration in detail. For now, let's summarize whatever we have learned so far. Velocity can be defined as the rate of change of displacement with respect to time. Mathematically, this can be written as velocity is equal to displacement divided by time. Instantaneous velocity can be defined as the velocity of a moving object at any instant of time. Average velocity for a moving object can be defined as total displacement divided by total time.